Today we have a new objective. We're going to be talking about the segment addition postulate. So you grab the notes and a calculator on the way in, hopefully, like it told you to grab the sheet and the calculator on the way in, okay? Now the calculator is mainly for computation, so maybe you got it all down in your head, but nonetheless, when they're out there, please grab them on the way in. They're not numbered, it's just grab it, return it, simple, okay? Reminder from day one, a couple days ago stuff, okay? So once we get started up here, I don't want headphones in our ears, please, 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 and please, and please. Thank you so much. All right, and over there, thank you. Now, make sure you turn in yesterday's assignment, sign student info sheet. Today, our warm-up is this two-step equation. Now, y'all should have, right? Y'all should have solved something like this in Algebra 1. I really hope so, okay? In Algebra 1, you should know how to solve a two-step equation. So, when solving this, how do I know I have this equation solved? What will it look like at the end? X equals, very good. All right, we want to isolate the variable, get the x, quote unquote, by itself, right? So right now, x has two buddies here. Got to get rid of both of these numbers, okay? So basically our goal is get rid of everything else. How do I, or which one should I get rid of first, the 3 or the -7? What do y'all think? Not the 3, okay? 3 and x are buddies. The way I say it is we want to get rid of the loner, the one that's kind of by itself, okay? It's the constant that we get rid of, but I call it the loner, why not? Get rid of those loners. Now, the way you quote unquote get rid of things, okay, is through inverse operations, which just basically means do the opposite. So the question is, what's the opposite of -7? +7, right? So underneath that -7, go ahead, and if you haven't already, go ahead and put +7. And remember, to keep things equal in an equation, you got to do whatever you do to one side, you do it to the other side. So if I have a +7 here, I'm going to put a +7 over here. Now, as I'm solving this, you're showing your steps, right? I'm not asking you to end solve and just write the final answer. I want you to actually show me your work, right? So the -7 and the +7 were opposites. So I can scratch them out. They go bye-bye. I'm going to bring down 3x, bring down the equal sign, and then 2 + 7 is 9, right? 2 + 7. Now, check this out. 3 and x, they're buddies. They're next to each other. There's nothing in between them. What does that mean they're doing? What's happening between 3 and x? Okay. If they're just next to each other like that, a coefficient is multiplying. Okay. Did y'all know that? Number in front of a letter? Okay. So yeah, multiplying. So what's the opposite of multiplying? Dividing. Cool. So anytime you see a number out front, in front of an x, divide. So divide by 3 on one side, divide by 3 on the other. Cancels out on the left side, so now I just have x equals, and then 9 divided by 3 is 3. That's it for that, okay? We got a lot to do on this notes sheet. So if you didn't get that sheet on the way in, okay, let's get in that habit. Make sure you have it. We are about to get started on these notes, okay? Anyone still need the warm-up? Okay, let's get started here. First thing I see on here is measuring segments, right? So the distance between 2 points, A and B, can be written as the length of AB. Let me draw here. The length of AB. Now on top of AB, I'm going to put a little segment symbol with no arrowheads. That's what it means to have a little piece of a line. It's a segment of a line. Okay, so write that down. Another way to write it is just with AB and nothing on top of it. Segment AB is how you would say that. And then look off to the right. How many units long is AB? When you start counting, think of that as 0, and then it's 4, 4 spaces in between those endpoints. Okay. Now, the next one, congruent segments. Y'all have heard of the word congruent before? Maybe? Congruent means, or do y'all know what it means? Congruent. Same size, same shape is a rough definition. That means congruent has to do with shapes, things you can see, okay? Numbers are equal, but shapes, those are congruent. So if I have congruent segments, then I can write it like this, AB equals CD. Those two segments are congruent. Off to the right, you can see them. They both measure 4 units. Then these segments are congruent. Okay? Now here's how you write a congruence statement. AB, with the segment on top, is congruent to CD. Now check it out. This weird thing is a congruent symbol. It's like an equal sign with a little squiggly on top, a little tilde. So anytime you see the word congruent, that is our symbol. It's an equal with a squiggle on top. Okay? That tells you those shapes have the same measurement and value. Okay, so the segment addition postulate. This is what we're getting to today with our objective. So off to the right, you see 3 collinear points. They're in the same line. And when you have 3 collinear points, that makes 2 parts. And then, of course, you have the whole thing. So the way I would write the segment addition postulate is the part on the left, AB, plus the part on the right, BC. If you add up those 2 parts together, it's going to give you all the way across, the whole thing. So that equals AC. Okay. The way I think about it is the left side has a part, the right side has a part, and if you add those together, you end up getting the whole thing. So again, the kind of generic way of saying it is part plus part equals the whole. Cool. All right. So we're going to use that to get started here on these examples. By the way, it is weird schedule on Thursday, so we get here at 12:55, so we got 27 minutes. Here we go. Now, this picture, we're going to use both 1 and 2 to do this picture. Okay? So first off, number 1, PQ equals 9. So imagine there's a 9 for this little part. Okay? QR is 28, so imagine there's a 28 on this part. Well, how do I find PR, the whole thing? What do I do with those 2 parts? Just add them up, right? Because part plus part equals whole. Now, go ahead and write very small, okay? But the way the technical way to set this up, right, is PQ plus QR equals PR. Part plus part equals whole. If I replace PQ with 9 plus replace QR with 28, that'll give me what I want, PR. So the question is, what is 9 plus 28? $37. $37. Did you say 27? Oh, okay. Sure? Oh, okay. I just couldn't hear you. 37. Very good. Now, same exact picture. Now look at this. It tells me QR is 17. So that's not a part or a whole. The right part. And it says PR is 21. Well, that's the whole thing, right? So that's not like the one we just did where you just add them up. Okay, I promise you, it's not just add up 2 numbers every time. That'd be too easy. So in this case, we know the whole, we know one part. What do y'all think I should do with the whole in the part to figure out the other part? We're going to end up subtracting. Yes, very good. Here's why. Let me show you. Once again, write really small. PQ plus QR equals PR. We're looking for PQ, so I'm just going to leave that as a PQ. But I can replace QR with 17, replace PR with 21. And kind of like our warm-up, if I'm trying to solve for PQ, I need to get rid of that loner 17. So what is the opposite of plus 17? Minus 17. So yeah, 21 minus 17 is 4. Okay, so we end up getting 4. When you know a part and the whole, you're going to subtract. Okay, now that's just straight up numbers. Now we're getting into expressions. Okay, stuff with X in it. All right, so let's look at number 3. I know it might look more complicated, and technically it is more complicated, but it's not impossible. We can do it. First of all, do I know the left part? Yes. Do I know the right part? Yes. On this picture is not labeled the whole thing, right? Like e.g., I don't know what it is just by the picture. But that's why, look up here, we want to read the problem. It tells us e.g. is 71. So that means I can label it on my picture, e.g. is 71. Cool. We're going to use what we were just talking about on these type of problems. We're doing part plus part equals whole. So you don't have to write out the like EF plus FG equals EG every time if you know what you're doing. So I'm going to skip over that step this time. I'm just going to cut to the chase. What is the left part you see there? The value is 8x minus 17. I'm going to put it in parentheses so I know it's one thing. Plus, what's the other part you see there? Five x minus 3. Sorry, you see what I'm doing? This part plus this part. And you're going to put equals the whole thing. You got the notes? You have this? Okay. Might want to get it out so we can see it. So left part plus right part is going to equal the whole thing, which wasn't on the picture, but it told us in the instructions that it's 71. Cool. 8x minus 17 plus 5x minus 3 equals 71. Now, if you can set it up, you're on your way. Right here, okay, could you solve this algebra problem? Okay, I am not asking you to end solve or math it with some weird app, okay? I want you to actually solve it. You can, as long as you will understand this when you get back. I mean, do what you need to do. So here's the deal. Let's solve this. X, well, sorry, multiple x's, right? Whenever you see like you have more than one x, you want to see if you can make this less complicated. You want to combine like terms. Do y'all see any like terms we can combine on the left? Okay, so there's x's and constant numbers. So again, because they're both on the left side of the equation, 8x and 5x can combine. So what's 8x plus 5x? 13x, very good. And then we're also going to combine these constants. So negative 17 minus 3. Now, not everyone loves adding and subtracting positive and negative numbers, but negative 17 minus 3 is, by the way, check it out. If you type it in your calculator, you would do negative sign 17 minus 3. It's negative 20. But if you do negative 17 and then a negative 3, they're going to think you're multiplying. It's going to give you the wrong number. Okay, so it's negative 17 minus 3. You should get negative 20. So minus 20 equals 71. Now look, doesn't that look like our warm-up? Two-step problem. So you should be able to get rid of the loner and solve. So what do I get rid of first? 13 or the minus 20? Minus 20 is the loner, so the opposite of minus is plus 20. I get 13x equals 71 plus 20 is 91. And then my last step to get rid of that 13 in front of x. What should I do? Okay, divide. The number in front of x, you divide by 13. Not everyone knows 91 divided by 13, but you can type it in your calculator and you would get 7. And that's what we were looking for, right? Find the value of x. You don't have to do anything else there unless they ask you to. If they ask you to plug it back in, you would need to do that, right? Okay. So please, you take it out. Number 4. Now we're not going to do everything on this page because we got to get to the back. We're going to run out of time. But on number 4, okay. Wait. Number 4, again, we're going to do part plus part equals whole. So what is that left part? Right here we have 9x plus 2 plus, what's the right part? 5. Now, it's supposed to equal the whole thing, which is not on the picture. But it's up here. TV is 14x minus 8. So TV, 14x minus 8. So that means our equation, part plus part equals whole, is going to be 14x minus 8 over here. Okay, this looks a little different than last time. Last time, both x's were on the same side. This time, x's are on different sides of the equal sign. So we're going to tackle it a little different, okay? But before that, let's see if we can combine like terms. Do you all see that 2 and 5? They're just regular old numbers, but they're on the same side, so you can combine those first. So I'm going to bring down 9x. 2 plus 5 is 7. 14x minus 8. All right, x is on both sides. Now, last time when x was on the same side, you combined them. But what do you do when x is on both sides? Do you combine them again or do something else? Do you know? Your teacher last year was horrible, right? Wow, it was me. That's the joke. I taught you this last year. Anyways, but when x is on both sides, you need to get rid of one because you can't have two x's, right? Okay, you don't want to have two x's on both sides, one on each side. So you need to get rid of one. My suggestion is get rid of the smaller x. Which x is smaller? 9x, right? So it's positive, so to get rid of a positive 9x, subtract, or minus 9x here, and on this side too, okay? So that cancels out the x's. Y'all with me with these phones in your hands? You. Okay. Bring down 7 equals, what's 14 minus 9? 5x, and then minus 8. Now I know this is kind of weird. X is on the right side now. Usually x is on the left, right? That's okay. On this side, what do I get rid of first? 5 or the minus 8? What's the loner? The loner is minus 8. What's the opposite of a minus 8? Plus 8. Plus 8 here, plus 8 here. 7 plus 8 is 15. And then get rid of that 5 in front of x by dividing. Divide by 5. Who could tell me 15 divided by 5? X equals 3. What if I told you that's not the answer? What are we looking for? TU, okay? Now you need to find X for sure, but you basically have one more step, okay? TU right here, between T and U, says 9X plus 2. So take that X, that is 3, plug it in right here where you see X for 9X plus 2, okay? I'm gonna just kind of write it off to the side. 9X plus 2 is gonna be 9 times 3 plus 2. 9 times 3 is 27. 27 plus 2 is 29. Okay. Okay. So since today's shorter, I don't have time to do numbers 5 and 6 with you. So on 5 and 6, you can put skip or just leave it blank. Flip it over, please. Because I need to go over midpoints with you real quick. Cool. Does anyone still need this page? Okay. Cool. So next page, we are going to see if we have time to come back to number 7. But don't skip number 7 yet. Just leave it blank. Look at midpoint of a segment. Okay. Write this down. Obviously, the midpoint. Y'all have heard this word before? Of a segment is a point that divides a segment into 2 congruent segments. Right? Cuts it right in half. And those are congruent, meaning they're the exact same measurement. Whatever one is, the other one has to equal it. Cool? Now, a line, ray, or segment that intersects a segment at its midpoint is said to be a bisector. Bi for 2, sect to intersect. So it intersects into 2 equal parts. The segment is called, and it is called the segment bisector. Bisector. So in the diagram to the left, what is the midpoint? B is the midpoint. Of what segment? So it cuts AC with the segment on top in half. And what is that line that goes through B? Remember, we can name it by the little script letter, so that's line L. And we would call it the segment bisector of AC. Okay? Write that down real quick, and we're going to do numbers 8 and 9 for sure. All right, now, number 8. 8 kind of looks like what we did on the front side, right? I see 2 parts. Why don't I just do part plus part equals whole? Well, here's why. Look, we only have 1 part, 2 part, and no whole. And it doesn't even tell us what it is at the top. Okay, so I can't do it on the way we did on the front. But since I know it's a midpoint, that makes me know for sure that each of those halves are congruent in their shape, equal in their measure, right? So here's one way we can write it. PQ's measurement equals QR's measurement. How do I know that? Q is a midpoint, okay? Anytime you see the word midpoint, that's the problem where you set them equal to each other, okay? So that's what we're going to do. PQ is 7x minus 16. That equals QR, which is 4x plus 2. Can you solve that? X is on both sides. Don't combine them. You got to get rid of the smaller x, which is 4x. So the opposite of a positive 4x, minus 4x, minus 4x. 7x minus 4x is 3x. bring down minus 16, bring down equals 2, and it's a two-step problem. We're going to get rid of the loner minus 16 by adding 16 to both sides. I ran out of room. So 3x equals 2 plus 16 is 18. And then last step, to get rid of that 3 in front of x, we divide. What is 18 divided by 3? What was 18 divided by 3? Anyone know? All right, good. It's 6. Are we looking for x in this problem? Yes. So you're done. Good. Is 9 similar? Yeah, 9's also saying h is the midpoint. So once again, that means you can set those halves equal to each other. So I can just skip to that step. 5x plus 2 equals 9x minus 10. Once again, x is on both sides. Get rid of the smaller x. Minus 5x, minus 5x. 9 minus 5 is 4x. And now you have a two-step problem on the right. I need to get rid of the loner. The loner minus 10. Hey, that's down. To get rid of that loner minus 10, we're going to add 10 here and add 10 here. 2 plus 10 is 12 equals 4x. And then the last step, to get rid of that 4, we're going to divide by 4. X equals 12 divided by 4 is 3. So on this one, we're not looking for 3 though. I mean, 3 is part of it, but we're really looking for GH. So take that x equals 3, plug it in right here where you see GH. So right here, instead of x, I'm going to put 5 times 3 plus 2. So 15 plus 2 is 17. Okay. If you understood 8 and 9, I think you could do 10 and 11. They're a little different because they're just a little different, okay? We're in the last 10 minutes. Sorry. But I did want to go back to number 7, okay? So just to mix it up. We do have a few more minutes than I thought we would have, okay? So does everyone have these two? I'm going to go back up to the top to number 7. So you could put skip on 10 and 11, skip these, okay? But at the top, number 7, we're going to do this a little bit faster since we're pros at this now, okay? So just make sure you have it down on your notes. Nothing is labeled here, right? But everything's in the instructions, so let's label it. SK is 13x minus 5. KY is 2x plus 9. And then SY is 36 minus x. Could you do, what are you doing? Could you do part plus part equals whole again? Okay. By the way, it doesn't say midpoint, so don't set them equal, right? You're going to have to do part plus part equals whole. So here's how you set it up. The left part is 13x minus 5 plus the right part, 2x plus 9, equals the whole thing, 36 minus x. What should I do first? Do I get rid of x's, combine like terms? What do you think? Okay, so first, always see if you can combine like terms. On the left side, I have 2 x's. Those make 15x. I have 2 constants. That gives me 4. Bring down the right side. Always combine if you can first, right? Now that I did that, I still have x on both sides. So could you get rid of the smaller x once x is on both sides? Which one's smaller, 15 or negative 1? Negative 1, right? So to get rid of that minus x, the opposite of minus is plus 1x, plus 1x. So 15x plus 1x is 16x, plus 4 equals 36. I know I'm moving a little fast because we're running out of time, okay? But we want to solve for x. Once again, it's a two-stepper. Get rid of the loner and divide. So the loner is plus 4. Let's subtract 4. 16x equals 32. Divide by 16. X equals 2. Once you have x, could you figure these other ones out? Like, can you plug them back into all three of them, actually? Okay. Now, I'm not going to show everything, but I guess I can try. So 13 times 2 minus 5 is 21. 2 times 2 plus 9 is 13. 36 minus 2 is 34. Now, that was me doing mental math, but if you slow it down, you could plug in 2 to each expression and get each of those values. And if you look at your final numbers, it works out. SK plus KY does give you SY. The part plus the part does give you the whole. Okay? All right. So I apologize how fast some of this had to be because we have a shorter class period and there's a lot to cover. But you have enough examples to be successful on tomorrow's assignment on segment addition and midpoint segments stuff. Okay? Keep these notes. Make sure you turned in yesterday's assignment. If you didn't get your student info sheet signed, I need it tomorrow. Tomorrow's last day, Friday. I need them. All right.